So in this video today, we're going to talk about cross sections and shapes of rotation. So by the end of the lesson, you're going to be able to determine what the shape of a cross section is in a solid, and you're going to be able to find the three-dimensional shape that's formed when a two-dimensional shape's rotated. So first of all, the set of all points that two or more figures have in common is their intersection. So when a plane and a three-dimensional figure intersect, the two-dimensional intersection is what we call a cross section, and that's a blank in your notes. So a three-dimensional figure can have many different cross sections depending on how the plane intersects it, okay? So the first thing I want to do is I'm going to show you this second video. So pause just a second and let me show you that, and it'll give you some insight as to what we're talking about today.
Math Shorts.
Slicing solid, three-dimensional figures results in different two-dimensional shapes, depending on how you slice them. If you cut through a cylinder with a geometric plane parallel to the cylinder's base, the two-dimensional cross-section is a circle. Any way you slice it, you can get two-dimensional shapes from three-dimensional figures. When you slice a cylinder from top to bottom that is perpendicular to its base, then look at the cross-section straight on. You get a rectangle. What happens when you slice a square pyramid? If you slice across the pyramid with your plane parallel to the pyramid's base, the cross-section is a square. If you slice with your plane perpendicular to the pyramid's base, the cross-section is a triangle. Remember, you're slicing a solid, three-dimensional figure with a geometric plane. You can slice in any direction. Just keep in mind that shapes can look different when you look at them from different angles. So orient the cross-section on the geometric plane. Slicing diagonally can produce different shapes, such as an ellipse or a trapezoid. Understanding the two-dimensional shapes that result from slicing solid, three-dimensional figures is important for geometry and ninjas.
So now we're going to talk about example 1. It says the plane is parallel to the base of the cone. The base of the cone is a circle. So any cross section made by a plane parallel to the base will also be a circle. So anywhere where we cut this cone is going to end up being a circle if it's horizontal, if it's going to be at the same place as the base. Okay, here if we cut through the apex of the cone, the plane is perpendicular to the base of the cone, so the plane intersects the base of the cone in a segment. The plane intersects the lateral face of the cone in two segments whose lengths are equal to the slant height of the cone. Therefore, the cross-section is an isosceles triangle. Okay? So now, I'd like you guys to go ahead and tell me what you see here as far as the different types of cross-sections. Go ahead and do this. Come back to me when you're done. Okay, so this first one I see is a square, right? So I'm going to write square here because my square doesn't really look like a square. The U try 2, rectangle, right? So I'm going to write rectangle here. Then U try 3 was a circle. I'm going to write a circle here. U try 4 through the apex. We already kind of talked about this one. This one's a triangle, right? So we're going to write triangle. Okay, now when we get down here, this is a pyramid, so this is going to be a square again. So I'm going to go draw a square and write square. And then U try 5 is a 5-sided object. We call that a pentagon, right? So 1, 2, 3, 4. Well, I'm not drawing this very well. Let's try this again. So 1, 2, 3, 4, 5. Okay, not very good, but it's a pentagon. Okay, meaning a 5-sided shape. Okay, so then for our U tries 5 and 6, go ahead and answer these questions and come back to me when you're done. So U try 5 says a right circular cone is shown. Which of the following figures could not be a cross section of the right circular cone? Okay, so obviously if we go through the apex, this would. If we go through the base, anywhere parallel to the base, it's going to be a circle. Now, if we were to do a diagonal, then we would get a sphere. So the only one here would be D, that is not a cross section. Okay. try 6 says the height of a right circular cylinder can piece is greater than the diameter of the base of the can. The can is sliced to 2 equal parts through its bases. Which of the following figures best represents the cross-section of the cylinder? So if we're looking at a cylinder, right, and it says the height of the cylinder canopies is greater than the diameter of the base of the can. The can is sliced into 2 equal parts through its bases. 2 equal parts through its bases means that we're going like that, right? Which of the following best describes the cross-section of the cylinder? So this would be a rectangle, wouldn't it? You got it. Okay, so now we're going to talk about rotational, what happens when we rotate a 2D image. So if we were to take this right triangle and rotate it all the way around, that means we're making this base a circle, right? So then what shape do we end up with? A cone, right, y'all? It is, okay? So then I want you guys to think about what happens when you rotate around the lines that are given. So if you rotate the solid below around the 3D dimensional object, around the line, what shape do you get? So go ahead and do these. Come back to me when you're done. So this one's going to be a sphere, right? The next one is going to be a hemisphere. And we just talked about C, didn't we? Basically, this is going to be a cylinder. Okay? So example 3 says a rectangle with a length of 10 inches and a width of 6 inches is shown. The rectangle is continuously rotated around the straight line to form an object with a volume of 150. And it really would be 150 pi, right? Because we're rotating it around an image, okay? So like, let's say we cut it here and we're rotating it. We're either going to rotate it that way or we're going to rotate it horizontally, okay? So, so let's just think, what is our radius here if we rotate it? This would be 5, right? So if it's a cylinder, and it would be, right? Because it's a rectangle. So it would be pi times 5 squared times 6, right? And that's 25 times 6. That's 150 pi, right? Now, if we did it the other way, if we rotated it this way, what would we get? So now we're going 3, right? And our height is 10. So we would do pi times 3 squared times 10. That's 9 times 10, which would be 90 pi, right? So it says about which line could the rectangle be rotated? A long side, a short side, the vertical line of symmetry, or a horizontal line of symmetry. So I say a vertical line of symmetry because that's the one that gave us. Now again, if we did it around one of the other edges, then we would have been 10 squared and 6 squared. So that again would not have gotten us the volume that they're giving us up here, which is 150 pi. So then it says a rectangle will be rotated 360 degrees about a line that contains a point of intersection of its diagonals. So let's draw a rectangle here. Point of intersection of its diagonals. That means it's being rotated about that right there, right? And it's parallel to one of the sides. So this would be parallel to the side, right? What three-dimensional shape will be created as a result of the rotation? And again, another what? Cylinder. You got it. Okay? So remember, anytime you rotate, you're going to end up with a round bottom. Okay? So it's either going to be a cone or it's going to be a cylinder, typically speaking. Okay?